Amen. Mighty Father, we thank you for this day. We thank you for this new day, mighty Father. We thank you that you've enabled us to pass through the night, mighty Father. Mighty Father, as we are going to study, as the teacher is going to carry out this lesson, mighty Father, help us to understand and utilize whatever he's going to teach us, mighty Father. Mighty Father, give him the energy to teach us and also give us the energy to understand whatever he's going to teach us. In Jesus' name we've prayed and believed. Amen.
Amen.
In the name of the Father, the Son, and the Holy Spirit. Amen.
Amen. Thank you so much, Jody. Good morning once again. Today, we are going to continue with a bit of mechanics. And like I promised, today we shall look at a bit. Okay, we shall go on and look at the component having different police systems. That's where we are going to concentrate. Now, looking at the mock papers, I found this number which could bring out the idea that I wanted to talk about concerning the pulley system. So could you take a minute to read it through? This was MEC Mock Examination Council, something like that. Yeah. So you read through. So when you look at this number, it had 3 paragraphs, and each of the 3 paragraphs had its own. When you look at the first one, was talking about forces, resolution of forces. When you look at the second one, it was talking about, it had the component of acceleration, it had a component of resolving. Then when you look at the third one here, it was talking about the pulley system. So we are going to work out all the 3 and then we break them into different parts. So allow me now to dig deep and we start. So when you look at the first part, they told you that a mechanical engineer visited a vocational training workshop to test 3 mechanics demonstration about force system, friction, and the pulleys. I don't know whether there is a problem. Yes, Baswali?
Good morning, teacher.
Yes, good morning.
Teacher, the screen is breaking.
The screen is breaking. Okay, can I know from others? Is the screen breaking? The screen is blurry. Screen is blurry. Okay. 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 Let me now, what about this? Let me know through the chat. What about this screen? Whether it's clear. Not really. Okay, let me first stop sharing and then I share again and you let me know whether now the screen is clear or not. Is the screen clear or not? Okay. Okay. So, okay. So on the horizontal table, a particle was acted on by a forces of magnitudes 30 Newton, 50, 60, and the rest of that. So what are they telling us? Now, when you look at our directions have been given in form of bearings. Whenever you find these three, these are bearings. What do you need to take into consideration? That also when you are giving your direction, the final direction, give it in the bearing format. Whenever you find three-letter digit, this is a bearing. Now we are going to say forces acting on the particle. Forces acting on the particle placed on the horizontal table. Particle placed on a horizontal table. Now let me say this is our particle. Now, since this is we are dealing with bearing, we shall start. When you look at our direction, I would always advise that if you find that you have such a case, you could first come up with, you can first draw, this is my compass. So you know very that this is the east, this is the west, this is the north, and then this is the south. So when you look at the first one is 30 Newton, and which direction was 060. So when you find 060, this one means you start from the north and you turn towards 60 degrees towards east. So when we are moving in bearings, we move in that direction. We move in the clockwise direction. So now we shall come here and then we say that now this is our force, which is, and you put the direction that this is the 30 Newton force. This is my direction. And then you show that now this is the turn and this is 60 degrees. So when I'm writing it on my diagram, I don't put the 0 because I have already measured. So I write it as 60. When you go to the second one, 50 and 90. So 50 and 90, when you turn 90 degrees from here, you will note that 90 degrees are going to land here. So this is where we have the 90. So here we shall have our force along this axis, and that one is going to be our 50 Newton. Then the next one is 120. Now 120, it still means that you measure from the what? From the north. So now I'm going to come and I'll measure from the north. Then I'll measure my 120. So that is the 120. However, since this is 120, I have a choice of either getting the angle I have here and I use it, or getting the angle I have here. So in case I want, I could get the angle here. So if I want to get the angle here, this is 120, but from here up to here is 90. So I could say 120 minus 90. So 120 minus 90, I end up with a 30. So I could use 30, another person could use 60, but all of them are very correct. So you use what you want. So you're going to allow me that now at this point here, I'll bring in my 120, and 120 goes on with the 60. So here we shall have the 60 Newton, and here now I'm going to put my 30 degrees. Then when you go to the next one is 100 and goes with 210. So still when you are measuring, you measure from here. So 210 is somewhere there. So now this is 210. Now you could either get an angle here or you get the angle you have here. Now since the whole of this is 210 and this is 180, I could decide to get the angle here, which is going to be 210 minus 180. So when you have 210 minus 180, still you end up with a 30. So now here I'm going to come and I have my line like this, and here I will say this is my 100 newtons. And yes, and which angle do I have here? That here I have my 30 degrees. Then the last one is 330, and 330 goes to this. Still, when you are measuring, we shall measure like this. So 330 is like in that position. Remember, this is 270. And here now you have 330. So you could say 330 minus 270. So when you say 330 minus 270, you end up with your angle here as 60 degrees. So that means that at that point, we shall come here and then draw our line and then say that this is 60 degrees. And then we shall say this is our 20 newtons. So that is now a simple sketch showing all the forces that are acting on our particle. Kindly let me know whether we are on the same page. Are we on the same page? Oh, okay, good. Now, after coming up with that sketch, after breaking it, after putting all the angles, now your next step is to start resolving. We say that when you are resolving, start with X and have the Y. So I'm going to say here, forces acting along the X, which you can call them f of X. So when you look at f of X, you note that what are some of those forces? You have the 30 Newton force. I say that when you have the 30 Newton force, where you can come here and then complete that triangle, then you know that this side here is where you have your opposite. This side here, you have adjacent. Then this is your opposite. Opposite is where you have your X. So to get the opposite, you know that opposite, you are going to use what? Sine of 60 equals to opposite, which is now your X, out of hypotenuse, which is 30. So mean that X will equal to 30 sine of 60. Now that is what I'm going to be writing along the X. So I'm going to come here. When I start with the first one of 30, you notice that I'll have 30 sine of 60. Now, when you look at the direction, once you resolve, it's going to be pointing this side. Then the next one is this 15 Newton. Since it is also looking this side, I'm also going to consider it positive. So remember, these are our positive, positive. Any force that looks here, it will be negative, and this will be negative. Then the next one is this force here. Once you resolve it towards here, it's going to be facing this side. So this is 30. So I'm going to call it that plus 60 cos of 30. Then come to this one of 100. So when you resolve it along the x-axis, it's going to be pointing in the negative direction. But since the angle is this side, then we shall say minus 100, then sine of 30. Then we have that 20. Still, when you resolve it, it's going to be pointing the negative direction. So I'll say minus 20 cos of 60. Members, are we together on that resolving up to that point? Because that is the core of resolving. Okay. Kindly go on and be completing. As I pick on Sissy.
Good morning.
Yes, good morning.
Yeah, pardon on how you came up with the diagram.
Okay, I'm going to throw more light. I'm going to throw more light.
Okay, thank you.
Now, when you look at the diagram, members, let's be completing. When you look at the diagram, they told that there are forces acting on a particle. This is our particle. Now, when you look at the force, they gave you the 30 Newton force and they gave you the angle at which it is acting. So that means that if this is the particle, This I've told you, whenever you find three letters, those are bearing. So it means that this force here is at 60 degrees. So if you come here, measure 60 degrees. And then that is how you'll have that 60. When you look at the second one, is 50. 50 is that 90. So from here, for you measure 90. 90 is going to follow here. And there you'll have your 50. The next one is 120. So from here, measure 120. So when you measure 120, here you'll have your 60. So this is where we have 120. But the angle you have here can be reduced. So when you look at this angle here can be reduced because when we are resolving, we'll resolve either along the y-axis or along the x-axis, meaning that the angles you measure must be angles close to the x-axis or angles close to the y-axis. So this one you will say 120 minus the 90, and therefore you get 30. So here you have 30, such that when you get this 90 plus the 30, you end up with 120. Hope you have picked something. Okay. So when you place your calc, here I'm getting, let me place mine quickly. Place your calc, and then we see what we get. And please always ensure your calc is not in radians. Yes, ensure your calc is not in radians. Otherwise, you'll get. So from my calc here, I'm getting 67.942286, and these are newtons. So these are my forces acting along the x-axis. Now next, I'm going to find my forces acting along the y. So I will say forces acting along the y. So that is f of y. Now, when you look at your f of y, what are you noticing? You start at, oh, here there is a force. You start again, the 30. Once you resolve along this axis, this 30 is going to be pointing in a positive direction. So meaning we shall have 30 cos of 60. Then when you look at the 50 Newton doesn't have any component doesn't have any y component. When you come to this 60, once you resolve it, it's going to be pointing in a negative direction. So that one we shall say minus 60 sine of 30. When we come to the 100 Newton, once you resolve it, it's going to be pointing down. So we shall have minus 100. And now here we shall say cos of 30. When we go to the 20 Newton force, the moment you resolve it, it's going to be pointing in the positive direction. So that one is going to be plus 20 sine of 60. So now the next thing you're going to do, you place your calc and find out what you are coming up with. So you place your calc, and then we see what you are coming up with. Okay, from my calc, I'm coming up with negative 84.28203. And these are newtons. Kindly, let's confirm before we proceed. So as I pick a hand from Davis.
Sir, good morning. My question is there any penalty?
Yes, good morning.
My question is whether there is a penalty when you resolve these forces combined as Fx below Fy at once. Thank you.
There's no penalty. If we are to use the vector format, it is very okay. There's no problem. Is that fine?
Yeah.
Yeah, there is no problem. The only challenge I said, the only disadvantage with it is that in case you make any error, isn't it 60 sine 30? Where is 60 sine 30? Yes, it is 60 sine 30. Philip, here. I think this is okay. 60 sine 30 for this. Then this is 100 cos of 30. Then this is 20 sine of 60. Okay. Members, are we on the same page? Are we on the same page? Yes, Cliff?
Good morning, teacher.
Yes, good morning.
I was asking, what if you resolve all the forces from the positive x-axis? Because that thing of negative, positive might confuse some of us.
Oh, like you resolve, but still the arrow, this arrow, even if you resolve it in anyhow, you need to look at this arrow here. Where it is going to point, because it is very important. So whatever approach you use, this arrow, the negative, and they will come in the play.
Okay. Thank you, sir.
Okay. I don't know. Could you share how you are going to resolve them?
Yes.
Could you share how you are resolving them?
Yeah,
How you avoid? Yes.
like for f of x, I had
Mm.
the 30 cos of 30 plus
Okay, for
50
this
cos.
one.
For
Okay,
which
for
one?
this one.
For that one is, it is 30. It is 30 cos of 30.
Okay, you have got this angle here.
Yeah.
Uh-huh.
Then for 50, it is 50 cos of 0.
Uh-huh.
Then when I come to that one of 60, it is 60 cos of 330 degrees.
330 degrees.
Yes. Yeah.
How did you get 330? For this of 60?
I'm taking all the angles from the positive x-axis, meaning I will have 360 minus 30 degrees.
Okay. Continue.
Then that one of 100, it is 100 cos of 240 degrees. Then for 20, it is 20 cos of 120 degrees. Then the final answer, I'm getting 67.9423 newtons.
Okay.
Mm.
It is okay. Go with the approach that you have. It is very fine.
Okay. Thank you,
Okay.
sir.
Okay. So we are going to continue. Now, the next thing, they asked us to get the net effect. Net effect is like the resultant. But I want you to, when you are making your sketch, please make the right sketch. This is positive and this is negative. So always start with the positive, with the x-axis. So when you look at our x-axis is positive. So meaning we are going to move like this. Now, where the force along the x has ended, this is the 67.9423. Where it has ended, I think it was like that. Okay, I have put 9423, 92286. Okay, 92286. Now, where it has ended is where you start with the y. Now, your y is negative. Negative means if this is y, you are going down. So mean that at this point, we are going to come down. And then you put for us that this is negative. You no need to put the negative because this arrow already shows you the negative. 84.28, 84.28203 newtons. Now what next? Now after coming up with that, the next thing is now getting the net effect. Net effect is the resultant, meaning that now you are going to get from the starting to the end. And this is what now we call the net effect. So you will say that the net effect and use this character, the scenario, what the language, the scenario. So the net effect, which you are going to call maybe R, will be given by, then you start now saying it's going to be given by the square root of 67.94228 squared, then plus your 84.28203 squared. So you place your calc, and then you end up with the answer. But I always advise that when you are placing your calc, make sure that you don't hurry and place such that you get the right answer. So from here, I'm getting 11,719.61481. I'm getting something like that. And when I get their square root, I'm getting 108.25717, and these are newtons. Now, this is the effect. However, they went on and asked you that also they need the direction. So the direction, I'm going to first find this angle, which I'm going to call alpha. So what am I going to say? I'll say that tan of alpha is equal to my opposite, which is 84.28203, divided by the adjacent, which is 67.942286. So alpha will equal to the tan inverse. The tan inverse, when you divide your 84.28203 divide by 67.942286, 84.28203 divided by 67.942286, you end up with something like 1.2405. So when you get your tan would be the angle 51.13 degrees. However, like I've told you that this is now going to be 51.13. But when you look at our question was giving us in degrees, in bearings. So you're also going to give in bearing. So now here I can first complete it in this form, Then I know that when I'm giving bearings, I start from the north. So I'm going to come here and I measure off from here. So what am I going to say? Now, I'm going to ask myself that this angle is 90. So I'll come and say now my direction is going to be 90 plus the 51.13. So you ask yourself, what are you going to get? So when you get a 90 plus 51.13, you end up with 141.13. But remember, these are bearings, so that means that you are going to approximate it. You are going to approximate it to, because those are 3 digits. And when you look at the 1413, so you can approximate to 141. Yeah, so that is going to be your direction. But if you want, you could leave it in this format as well. And now here, since when you look at the question, they were putting degrees, so you will come here and also add that these are the degrees. But first put this before you approximate it to 3 decimal places. Another person, in case you are giving it in bearings, another person could get this angle here. Another person could get that angle. Then you say 90 minus 51.13. So that person will get here 38.87. But this one being south and you are turning towards the east, someone could say south 38.87 towards the east. However, I wouldn't recommend this approach for 1 or 2 reasons. In fact, here, we can leave it to 2 decimal places. But if you want, there is one, so it would be okay. Then someone could write it in this format. But when you look at all the bearings that were given in the scenario, they were given in 3-digit form or 3-digit form. So here, the best recommended one would be this one. Much as this one is also correct. But since the scenario was matching this format, I would advise that we use this format instead of this format. Okay, can I pick one hand? And then you let me know through the chat whether we are on the same page. Edwin?
Yes, good morning, sir.
Yes, good morning.
Yeah, I came in a bit late, and I would like you to go through the other part of resolving, because I saw like things that are confusing me there. Like when you're resolving, I thought you were supposed to use like the cos like for vertical resolution, and then sine for the vertical one. But I'm seeing something different there. Would you please help me like go over it like just very quick?
Okay, Edwin, I will go through it at the end. I'll go through it at the end.
All right, sir.
Yeah, but one thing you need to know, it's not a must. What matters is not that thing. Teachers just do it to simplify your work, but it's not that always what you need to look out for. Even if you have here 30, for you what you need to look out for, that this is X and this is Y. So when you are resolving, you are looking for X and Y component. So if the angle is here, to obtain X, if this is the angle, this is your opposite, this is your adjacent, and this is the hypotenuse. So in case this is 4 Newton force, for you what you need to know is the X. What is the X? Then you need to know that if X is at the opposite, I am going to use my sign of 30 equals to opposite out of the hypotenuse. That where is my adjacent? That is cos of 30 is equal to adjacent out of the hypotenuse. If you find that maybe the angle is maybe in this region here, and this is maybe your 60, for you just know that this is your opposite, which is y, and your adjacent is x. So for such a case, you will say cos of 60 is equal to adjacent, which is going to be x out of the hypotenuse. Let me say it is 5 out of 5. So meaning that along the x, it will be cos. Then when it comes to sine of 60, it will be now y out of the adjacent, which is 5. So meaning that along the y, I'll use sine. So it can differ depending on where the angle is being placed.
Okay, so wouldn't I be like penalized if I just like resolved all those other things for cos, and then for cos horizontally, and then for x vertically?
No, there is no any penalty as long as you are getting the right things.
Okay.
Okay.
All right, thank you.
Yes. Excuse me,
Yes,
teacher.
Rocky.
Teacher, for me, my question is about that angle of 51.13. Teacher, is there any penalty for me if I stop there on that angle? Excuse me, teacher.
Rocky, continue. But let me hope.
Teacher, my question is about that angle 51.13. Teacher, is there any penalty for me if I stop on that angle?
Okay.
Excuse me, teacher.
Yes.
My question was about the other angle that we first
Yes.
got.
Mm.
That angle 51.13. Teacher, would I be penalized if I stop at that angle?
If you?
If I tell I had stopped on that angle?
Yes. Now here you'll have a penalty. Why? When you look at the angles the scenario has been giving us, it has been giving us a complete bearing. So that's why you have to go on and write a complete bearing. When you say this is the direction, here you need to accompany it with the words that below the positive horizontal. But of which for that case, here you are only looking at the degrees. You are not looking at bearings. So you need to study the scenario and ask yourself, what is the scenario giving? That it is giving bearing. So mean that also when you are responding, you give in bearings. But if we were just giving angle 60-30, then here, still even you don't stop here, you go on and accompany it. Because when we are measuring angles, we always start from the positive x-axis, going in the clockwise direction.
Okay. Thank you so much, teacher.
Okay. So here they have told us that we have a rough. So rough, we say that whenever you find something rough, it means that you need to expect that there is a frictional force. A horizontal plane. Plane means something flat. Using a string inclined at an angle of 20 degrees above the horizontal. The tension in the string was 25 newtons and the block accelerated at 4 meters per second squared. The engineer notes that the nature of the horizontal surface was affecting the motion of the block and wanted to determine the coefficient of friction between the block and the surface. What do you need to do? You'll come up with a sketch. Now, a sketch showing your thing. So let me assume that this is our horizontal plane. And on our horizontal plane, they have placed there our block, which is 4 kilograms. So I'm going to come here and say this is our 4 kilogram block. Now, we know very well that if something is being placed on the table, there are forces acting on it. And one of the forces is what you call the reaction force. So when I come here, I'm going to have my reaction force. Now, our reaction is always equal and opposite. So down here, we shall have our weight. And you know that weight is given by mass times acceleration due to gravity. So since this is 4, here we shall have 4g and then newtons. So here we don't indicate the give there and there. Why? Because we are still resolving and want. So here we shall put 4g newtons. Then it is inclined at an angle of 20 degrees. Now here someone is pulling this block. But so if we are pulling this block, it means that there is a rope here that someone is pulling here. So this lock, they have told us it is 25 newtons, the tension in it. Because you know very well that in any rope, depending, we shall have tension. So the tension in the string, which is T, is equal to 25 newtons. Someone is pulling. But this tension, the string is inclined at 20 degrees to the horizontal. So let me come. So this is where I have my 20 degrees. Because this string, you are pulling it at an angle. Then they went on and told us, and the block accelerated. So this block is moving. But at what acceleration? It is moving at 4 meters per second squared. Now, remember this is a rough surface. Being a rough surface, there is friction force. And now since this is the direction that it is taking, then it means that friction force always acts in the opposite direction. So this is Fr, which stands for your frictional force. Now that is a simple sketch of your diagram. Members, are we on the same page? Kindly let me know whether we are okay up to that point. Okay. Okay. Now, after coming up with your diagram, the way it is here, then the next thing is to resolve. Now, how are we going to resolve? Now, we know very well from Newton's laws of motion. What do we know? Allow me to start writing from here. From Newton's laws of motion, you know that force is always equal to mass times acceleration. Now, what do you need to know? When you look at this 25 newtons, 25 newtons has two components you need to look out for. Number one, this Newton thing has a vertical component. This. It has also a horizontal component. Like I've told that for what you do, you get your angle, label it that this is my opposite and this is my adjacent. So my opposite is like your y, your adjacent is your x. Then come, in case I have sine of 20, sine is opposite, which is going to be y out of the hypotenuse, which is 25. That means that along the y, you are going to have 25 sine of 20. That means that the tension along the y, when you resolve along the y, here, your tension is going to be 25 sine of 20. When you resolve cos of 20, cos of 20 is given by adjacent, which is x out of the hypotenuse. That means that the x component for your tension is going to be 25. I'll have 25 cos of 20. That one, you take note of it. Now, forces acting here. I'm going to start with the reaction. When you look at the reaction is facing up. So, which other force is facing up? You have this reaction, but also this tension is facing up. That tension is also facing up. Since the tension is facing up, you are also going to take into consideration. So now I'm going to come and say that R plus our tension, which is 25 sine of 20, should equal to 4G. And this comes from force is equal to M of A. So here at this point here, the forces acting up, we have reaction, we have this tension, but all that is equaling to the downward force. Members, have you understood that step? That one. Have you understood? Because now we are going to get now our reaction. Have you understood up to that point? I repeat, you know, I am going to repeat, reaction is equal and opposite. Now you ask your forces. Here, I know you might have looked at forces down is equal to the forces that are up. When you look here, when you resolve this tension here in the string, the tension faces up. And this reaction also acts up. So upwards, we have two forces. We have this force of R and we have this tensional force. Those are forces that are acting upwards. In other words, you have something like this. You have R and you have another one, which is 24 sine of 20. Then downwards, you have your force, which is F4, 4G. Now, it means that these forces acting upwards, R and 25 plus sine R, must equal to the other forces acting downwards. Because here when we are finding, we look at the forces acting on the particle. This tensional thing is acting on the particle. So that means that you have R plus 25 of sine 20 is equal to 4G. Members, is it fine now? Is it okay now? Sum upwards is equal to sum downwards. Okay. Okay. Paper saying it is okay. Baswali?
Teacher,
Yes.
for me, according to me, how I have understood this,
Yes.
like we know that F is equal to MA.
Yes.
So where there is my F, I will substitute R plus 25 sine 20. I put them into bracket, then I subtract the 4G and I equate it to MA. But I understand that horizontally, acceleration is 0. Then my MA vanishes to 0.
Yes.
Then
That is
from
very
there, I
correct.
just... Okay, thank you.
Yeah. So if you use that, then you know, remember this is resultant force. So then you could say plus your 25 sine should equal to mass, which is 4. So R will equal to 4G minus 25 sine of 20. So our R will equal to 4 times 9.8 minus 25 sine of 20. So my R is equal to, so you place your calc. And always for your G, look at your question paper. Sometimes some of you who do physics, you confuse this G with that one of physics. So here, when I place my calc, I'm ending up with 30.649496 and these are going to be newtons. Like I've always advised that if you have not yet reached your final destination, always go on and fast write to as many decimal places as you can. Then after getting our R, we are going to ask ourselves which other forces are acting on a particle. Now, still from our force, our resultant is equal to M times A. When you look at the forces, you have this force that is pulling horizontally this side, which is 25 cos 30. But because the body is moving towards this side, we shall call it 20. So here we shall have our 25 cos of 20 minus, because friction force always acts in the opposite direction, we shall have friction force is equal to our mass, which is 4, times the acceleration, which is 4. So we shall have now here 25 cos of 20 minus F of R equaling to 16. So after getting that, we are going to take the FR this side, we bring the 16 this side. So we can say 25 cos of 20 minus 16 is equal to F of R. So that is what I'm going to have. So at this point, I'll say F of R is equal to 25 cos of 20. Then I've said minus our 16. But you know that F of R is the same as mu of R. So when I place my calc this side, I have 25 cos of 20 minus 16. So I end up with 7.49231552. But I've already obtained my R. So we got our R. Our R was 30.649. Our R was 30.649. 649.642 is equal to 7.4923. Here, even if you write to 4 decimal places, it is very okay. So meaning that your mu will equal to 79231552 divided by 30.649499642. So when I divide those two, I'll get my mu as, I'm getting here my mu as 0.2445. That is what I'm getting for my mu. Remember, mu does not have units, so we shall not have units. So that is what you can get. So let me pick a hand from Esther. Esther, you can ask.
Good morning, teacher.
Yes, good morning.
Okay, my question is on the previous slide where someone talked about how the acceleration was 0. But then in the question, you also give us the acceleration as 4. So now I'm a little bit confused.
Oh, now the acceleration becoming 0, you are finding forces acting on this. Are you seeing this particle?
Yes.
Now, when this particle has not yet started moving, what happens is that there are forces that act on it. Now, the forces that act on it, they just make it intact into that place, but they don't move it. Like these upward forces and downward forces, they cannot move that force into this direction. Do you agree?
Yes.
Yes, so that's why we say acceleration is 0.
But then for the horizontal, it's where it's 4 because it's moving with M.
Aha, perfect. That's why here we said M times A. So your A was given as 4 and mass was given as 4.
Oh, okay. Yeah, thank you so much.
Okay. Arnold?
Good morning, sir.
Morning.
Teacher, I was trying to resolve whereby I got the frictional force and subtracted it. I got FR minus 25 cos 20 is equal to 4A. Then I continued by doing mu R minus 25 cos 20 is equals to 16. After I had to take the 25 cos 20 that I said making it to be 16 plus 25 cos 20. But I'm getting a different answer, which is 1.3.
Now, number one, Arnold, you'll never have your mu above 1. The moment you get above 1, it means it is not correct. Number two, I am not saying as if you forgot. You had this.
Which one?
Because when your statement was, you said mu r, you said 25 cos of 20.
Yes. No, actually, I said mu r minus 25 cos 20.
Mu r, come again, mu r minus?
Yes, 25 cos 20 is equal to 16.
Now that's where the problem came from. Because from you here, you are telling us that this frictional force is greater than these forces this side. So it's like this is what is pulling, that the frictional force is the one that is pulling. But friction always resists motion.
Yes.
So that's where the problem is. Because the movement of this particle is towards this side. So it is supposed to be 25 cos of 20 minus mu r equals to 16.
Yes, sir. Thank you so much.
Okay. Okay, now let's proceed to the next part. Now the next part here, they are telling us that in the pulley section, a light inextensible string attached to the ceiling passed under a smooth movable pulley of mass 3 kilograms. Then over a smooth light pulley fixed at the top of the inclined plane. Here there are two things that are coming up. Now, number one, you are not saying that you have two pulley systems. You have a smooth movable pulley that is attached to the ceiling, and you have another light pulley that is at the inclined plane. So here, your diagram is going to have two things. You are going to have your ceiling with the pulley, and you are going to have your thing. But allow me that I first summarize a bit of pulley systems, more so for one part. Which part? The part of acceleration, because that is one of the things that we need to pay attention to. Now, when it comes to these pulley systems, more so when you have two, there are different cases that you are going to be meeting. One of the cases that you can meet is this case. It can be a case where you have an inclined plane. This is the inclined plane, whereby on this inclined plane, you have your pulley here, and this pulley here is attached to a mass. And then you'll find yourself that under here, you have another pulley that is movable, and then this pulley may be attached to something. It can be something of that nature. Now, like always, I've told you that this pulley may have a mass. Let me say this is mass 1, and maybe this is mass 2. So you put your forces, that here our forces, we shall have M1G. For this one, still you do your resolving. I'm not going to do all the resolving, but okay, allow me to do it. This is theta. So this is theta. So you know that here along here, you are going to have your m of 2 sine of theta. Then along here, you are going to have r. Then down here, you'll have your m of 2 cos of theta. Then here is where you have your m2g. Now, remember, under the Pulley systems, you must have the tension in the string. Now, if this string is the same throughout, are you seeing? If the string is the same throughout, then the tension is always the same. So this is tension, this is tension. Along here, you'll have your tension. Along here, you'll have your tension. Along here, you'll have your tension. And down this side, you'll also have your tension. Now, those are the different forces acting on it. Now, depending on which mass is bigger than the other, then that is what determines the kind of motion of the pulley. Depending that in case this is bigger than the other, then you need to know that which one is bigger than the other. So in case this is our pulley system and we are moving. So if this pulley system, let me say it is coming down, assuming that this is the bigger mass. Let me say this is around 20 and this is around 10. What is going to happen? That this body is going to be moving this side. As that body is moving that side, this body here, it's going to be moving where? Downwards. Now, where is the key thing? The key thing is in the acceleration. The key thing is in the acceleration, and that's what I want you to understand. You know very well that distance is equal to ut plus a half at squared. But since this system is being released from rest, it means that your distance s is going to equal to 0 times your time plus a half of a t squared. So here your distance s is the same as a half of a t squared. Now what are you noticing? Time is constant during the motion. Like it will be the same for the two bodies. Now what are you going to notice? Here I can write it that my s is directly proportional to a. Now I want to let you know that whenever you are dealing with things concerning this kind of pulley system, your acceleration is proportional to the displacement. So your distance is equal, or I can say distance and acceleration are directly proportional. That if the distance you have moved is 1 meter, your acceleration is going also to be 1 meter. So when you are dealing with with this acceleration, for you to be able to understand them very well, you look at the distance being moved. That if this is your body, this is our body, and this is our body, ask yourself, what distance have they moved? Take an example. For the body that we are looking at, for this particular body that we are looking at, when you look at it, is that when this body is pulled, let me say this is or this is where it is, this is where it is. What is going, let me say this is or this is where the pulley is. What happens that when this pulley comes down, when it is being pulled, when it comes down, because it is pulling the body, it will come, it has to move. Are you seeing? This string will have to move here. The string will have to move somewhere here. Meaning that this body is also going to move where? Upwards. What does it mean? That the distance that this particle here moves is different from the distance that this particle moves. One of the particles moves a bigger distance compared to the other. Why? when you look at our thing, I'm going to use this as my reference. If from here up to here is x, and from here up to here is my x, this particle has to move this x, has to move up. But this particle here, it moves it in a combined form. So let me call this one. Okay, I'm going to first use that approach. Let me first use the first approach to check whether members will be able to Okay. Let me first use this approach to check whether members will be able to understand. Now, what are you noticing? That the distance that this particle M2 is going to move is going to be twice this distance, because this particle X has to come here. So when it moves, it's going to come here. That's going to be our first X. Then this X here is also going to move where? Upwards. So this one will extend where? Upwards. So meaning that the distance that this particle here has moved is going to move this distance x, maybe up to here. It has also to move this distance here, which here is going to be x. But this particle in a combined form, this one will come here and it goes up. So here, the distance that is going to be moved by here is going to be x. So the total displacement moved by this pulley, by this mass, is going to be 2x. But the distance moved here is only going to be x. Because this x here, when you look at it practically, it's going to move down here. So this one x is going to move here a bit, the whole of this, and then this one will only extend by x. So mean that if this one moves to x, this one is only going to move x. Members, first let me know through the chat whether we are on the same page on that. Kindly let me know through. No, G is there. G is here. Don't forget to put it there. G is there. People are saying not yet. I'm going to repeat because you need to know how they move. I repeat. When you look at this pulley system, let me say from here up to here, you have a distance which is 1. And from here up to here, you have 1. Now what happens that for these pulley systems, when it is moving, like this string here must rotate around it. So what happens that this one, this string here, the half of it is going to come like this. It is going to come down. As this half comes, this one goes up. So you'll find that almost one of it is being put here. Then up here, it's only going to move 1. I don't know whether I need to put it here. That when this string is moving, like now it is coming down, you'll find that it has to come here and then it comes here. Because the second option I can use is when I take you to the other part, that if this is x and this is what? X. And this distance here is, let me say, y. What am I going to do? It means that my total displacement is going to be y plus x plus x. Now, the length for the total string is constant, is the same. So, which I can call L, but it is constant. It does not change, the total length. Now, here what do I have? I have y plus 2x. Assuming that this is going to be, the string is coming down. This is my acceleration, which I've called A1. And this is my acceleration, I've called A2. Now, I'm going to use your knowledge of differentiation because that's where it comes from. Now, when I differentiate, I'll have the y with respect to time. Plus, when I differentiate this, it will be 2 dx with respect to time. When you differentiate a constant, why a constant? This is the length of the string. The length of the string does not change, so it is 0. What are you not seeing? You know very well from your knowledge of calculus that our dy dt, when you have dy dt, that one stands for your velocity. So meaning that dy dt is the same as velocity. Now for dy dt, I'm going to look for it as the velocity 1, which is for this particle here. So this is the same as velocity 1. plus 2, which is the velocity of 2. Now, velocity of 2 is for this particle here, is equal to 0. Now, what are you noticing? That when you differentiate this again, you'll have your dv dt plus here you have 2 dv2 dt equals to 0. But what do you know about dv dt? When you differentiate velocity, you get acceleration. Now, our v1, which I've called y here, is going to be your a2. Because here I used a2, so it becomes a2 plus 2 divided 2, which I called this dx, is going to be a1 equals to 0. So meaning that your a2 is the same as negative of 2a1. Now, that's why when it comes to such systems, you'll find that I'm going to first clean this. This was your A2 and this was your A1. You'll find that when you are putting its acceleration, when A2 is always twice the first one, the movable pulley, that if this is A1, this one here is going to be 2 of A1. That's where it is coming from. But it can originate from this kind of knowledge. But this negative, it just shows you the direction. So it means A2, this one A2 is going to be twice of A1. I don't know whether you have got that approach, but I'm just showing you how it comes about mathematically. Kindly let me know through the chat as we continue.
Excuse me, teacher.
Yes, please.
This first pulley, which is holding the mass, is a single movable,
Yes.
isn't it? And this one,
This
which
one
is
here?
moved, that one is single. Is it fixed? Single fixed pulley?
No, this is movable, light movable. This is the one that is fixed. Okay. So now what do you need to know? One thing now I want you to know is that if I have such a system, if this acceleration is I'm going to call it A1, the acceleration you're going to have here is going to be 2A1. Now, please take note if the system is like that. If now I've started now to give you different cases such that now you know how to deal with them. So here it is the acceleration that will let you down. Then I know depending on the book you are reading, you'll find some books, if here it is A, here this one is going to be A out of 2. Please take note that it is always a half the other. Yeah, so if we use here A, this one will be a half of A. So please take note of that. This is the second option or this is the second option, depending on how your teacher handled that. Okay, then the other case that we can have when it comes to the pulley system, the other case that maybe I would bring to your attention, I could give you another case here that we could have. Another case that you need to be a bit more careful with is when you have multi-pulley systems. Let me say you have this one here. I just want you to know how to get the acceleration because we are going to deal with it. Then the other pulley system is where you have a number of pulley systems. Let me say you'll find a pulley system whereby this one is a pulley, and on this pulley they have attached a mass. Let me say this is my mass. I'm calling M3. Then on this they can put a pulley system. Let me say they have put a pulley system, and let me say this is A, and on top of this they have also put another pulley system. No, not a pulley system. Let me say they have put a mass and also they have put a mass. Now, for such a case, please also be very careful. Allow me to just call this one to be M1G and also this one to be M2G. Don't forget that you have tension. This is M3G. What are you noticing about these pulley systems? When you look at the string, this is one string. Then when you look at this is another string. If the strings are different, it means that tension is also different. In other words, if this one you have decided to use T1, this is going to be T1, T1, and then this is going to be T1. Now, since this string is not the same as this one, please here change the tension. Call it T2, call it T2. Then here, you'll also call it T2. Also here, you'll call it T2. So tension change if the strings change. Now, assuming that this body, these masses here are bigger than M3, and our body is maybe moving like that. Now, if our body is moving like this, what is going to happen? That if this body goes up with, I'm going to give it an acceleration. Let me say, I'm going to give it a 1. What happens that when it comes here down, here, this body is also going to be moving where? Downwards. But I want you to take note that if this body is moving, I want you to take, if it is moving up like this pulley system is going to pull where? Downwards. But as this pulley system is pulling down, remember it also has the masses attached to it. So what is going to happen? Now, this one here, in case this one is bigger than this, let me say this is, in case this is 3 and this is maybe 4, this one here, its acceleration is going to be going up, and then this one goes where? This one is going to be going where? Downwards. Now, you will notice that now the acceleration is going to be what? Different. Now, that is what now I want you to take note of. That now, this mass 2 you are going to have, let me say it is A2. Its acceleration is going to be pulling it down. So what do I want you to take? Because I've said that acceleration is proportional to the displacement. That means that the acceleration for this one is going to be A1. When it comes to this pulley system, we shall have our A1 because it will move the same distance. If like when you look at this, if it moves Y1 up, also this pulley system is going to move where? Y1 downwards. So their accelerations are going to be the same. But for this particular body here, down here, it is going to move this Y1 distance, but also it has to move up because it is being pulled. I don't know whether, in other words, if this body moves Y2 downwards because it is pulling, this body here is also going to move Y2 upwards. But I've said that this Y, the distance it moves, is proportional to acceleration. So if this acceleration was A2, what about this one? This one is going to move with an acceleration of A2 and A1. So for this case, this particle here is going to be acted on by 2 accelerations. You have an acceleration that is pushing it up, and you have an acceleration that is putting it down. So that means that the resultant is going to be A2 minus A1. What about for this particle here? This particle is going downwards. So it's if the acceleration of going down was A2, what about this pulley system? This pulley system was also pushing downwards. So its total acceleration is going to be A2 plus A1 because A1 and A2, all of them are pointing in the same direction. So that's why we add. Now, if you find the pulley systems of this nature and you are trying to get the acceleration, in case the pulley system is going up here, it means here you have A1. For this particular pulley system, it will move the same distance. But these two bodies here, they will have a combined acceleration. So this one can be A2 plus A1, depending on which body is bigger. Then this one will have your A2 minus A1. So please take note of that. So that is very important when the pulley system is in that form. In that form. So it depends on how your bodies have been aligned. Yeah, so that is the second case that you can meet. So please look at those different cases and then you resolve accordingly. So I'm going to go back. These are some of the special cases. The rest of the cases can, but the only one that I want you to take note is this one here. That when it depends on the book you are using and it depends on the distance that is being moved. But one thing I want you to take note that whenever you have such movable pulleys, these movable pulleys, its acceleration is always a half, or its acceleration is half of this particular acceleration this particle moves. Okay, so let's start now on our item. So they told us that in our item here that we are dealing with, in a pulley section, a light inextensible string attached to the ceiling, that you have your ceiling. This is our ceiling that we have. And there is a light inextensible string. So I have my string here. This string is attached to the ceiling and it passes over a smooth movable pulley. So let me say this is our pulley system and this is the string and it will pass there. Then they went on, but the pulley is of 3 kilograms. So this pulley here has 3 kilograms. So here I'm going to come and say this is 3 G newtons. Then I continue. Then over a light pulley fixed at the top of an inclined plane. So I have an inclined plane here. This is my inclined plane, and on the top of it, there is a pulley. So this is my pulley, and then it comes like this. And here, inclined plane at 30. So this inclined plane is put at 30 degrees to the horizontal. They told that is attached to a body of mass M. This is our body, which is M kilograms. Then we continue. The coefficient of friction between the body and the plane was 0.25. This is the body and this is the plane. So we are going to put that this is our frictional force, which I'm calling F of R, and was 0.25. And when the system was released from rest, the M kilogram mass covered a distance of 2 meters in 4 seconds along the plane. Now, let me assume this system has been released from the rest, so it's going to move in that direction. But the distance it covers is 2 meters in 4 seconds. Remember, it is being released from the rest. What do you need to know? Since the body is from rest, it means that your initial velocity u is 0. And what is the distance it moves? That is displacement is 2 meters. After what time? The time was 4 seconds. So what do you need to know? It means that you can use this relation to be able to get the acceleration. So I can say S equals to ut plus a half of at squared. What is your S is 2. We have said this is 0 times 4 plus a half times a, then times t, which is 4 squared. So meaning we shall have our 2 equals to 16 of a divided by 2. So this is 2 equals to 8 of a. So when we divide through by 8, we shall end up with 1 out of 4 equals to our acceleration. So meaning that your acceleration is a quarter mass, that is what? Meters per second squared. So that is the acceleration. So meaning here, when you are looking at acceleration, we shall use a quarter as our acceleration. If you want, you could convert it into decimal 0.25. So I can use 0.25 meters per second squared. I'm taking an assumption that our body is moving in this direction. Okay. Now, after that, I am going to continue and I resolve such that I find the forces acting on our bodies. So here, when you resolve, you know very well that along this side, you are going, okay, we start with our weight. Our weight here is going to be mg newtons. Then along here, we shall have our mg cos of 30. Then along here, we shall have our mg sine of 30. Then up here, we are going to have our reaction R. Then here, we shall have our tension force. And since the string is the same throughout, this is still tension. And then this is still our tensional force. Now, I have put all the forces on my I've put all the forces acting on my particle, And now my next part is to find out whether this mass M is equal to 8 kilograms. So now you are going to work out body per body. So I'm going to start with the 3 kilogram body here for this movable pulley. But remember one thing that I want you to take into consideration, that if this acceleration is 0.25 for the body, you ask yourself, this particle is moving this side, this pulley is going to move downwards. Now, what is going to be its acceleration? Put for me in the chat, what do you think is going to be the acceleration for the pulley? What is going to be?
It is going to be 1/8.
1/8. Aha, very good. So like we say that if this acceleration here is A, then the acceleration here is always a half, so it's going to be A out of 2. So since we got our acceleration as 1 out of 4, so for this case here, we shall have 1 out of 8, and these are going to be meters per second squared. So please take note of that. In case you are using decimal points, then you divide by 2 and use, or you can use 0.125 meters per second squared. Now for this particular body, what are you noticing? Since the body is moving downwards, our force will equal to M times the acceleration. But this F is the resultant force. Now when you look at our force, you have this force here and you have the forces acting up. So when you look at that body, when I break it, I'm going to break it a bit here. When I break it, you have something like this. And down here, you have your 3G Newton force. Its acceleration here is 0.125 meters per second squared, or 1 out of 8. Then up here, it has the tension, which is T. It has another tension, which is T. Meaning that upwards here, the total force is T plus T, which is 2T. But since it is going downwards, it means that this weight downwards is bigger than the upper one. So meaning that our FR is equal to MA, we shall have our total force as 3G minus our 2T is equal to the mass of the pulley, which was 3, times the acceleration, which is 0.125. So here I'll get my 3G minus 2T is equal to 3 times 0.25, 3 times 0.125, you end up with 0.375. But I can obtain my T. Why? Because I can make it the subject. So I can have 3, G is 9.8 minus 2T is equal to 0.375. So what is 3 times 9.8 is 29.4 minus our 2T is equal to 0.375. So you are looking for T, so you make your T the subject. Take it this side and bring the other one that side. So we shall have 29.4 minus 0.375 equals to 2T. So when you subtract, you'll end up with 29.025 equals to 2T. Divide by 2, divide by 2. So when you divide by 2, you'll end up with your answer as 14.5125 newtons. And that is your tension. Now, after getting the tension, we are interested in the mass. So look at our body, the inclined plane. On our incline here, remember here we had our mass, which was mg sine of that. But also they talked about friction here, which is F of R. We have our acceleration, which was 0.25. So you have your acceleration here as 0.25. Then up here, you have your tensional force that is pulling. Then you have your reaction here. And then you have down here your mg cos of that. Now, those are the major forces that are acting on our particle. Now, since our body is moving towards this side, it means that the tensional force is bigger than all these two forces combined. So that means that we shall say our tension force minus all the forces down, which is F of R plus our mg sine of 30. But this one is equal to mass times A. So our mass is M times our acceleration, which is 0.25. So what shall we end up with? We shall end up with T minus F of R plus M of G sine of 30 is equal to 0.25 of M. Now, when you look at our R, you note, when you look at our friction force, friction is M mu R. But the question gave us our mu. When you go back to the question, your mu was 0.25. So we are going to substitute it. So it is 0.25 times our R. When you look at our R, you notice that R is equal to mg cos of that, because there is no any other force acting downwards. So here we shall multiply times m times 9.8 cos of that. So I can come and say where there is where I can multiply through, and I say cos of 30 times 9.8 times 0.25. So I'll end up with my answers 2.121762, and this is my frictional force, and those are my F. So when you multiply, but remember there is an M here, so I'm going to put it back, M, and then I put newtons. Please take note, this M doesn't disappear. It remains there. It remains on that point. So that's what you are going to have. That means that when I come here, I'll substitute it there. So I'm going to have, we have already obtained our T as this, so I can substitute in for our T. So I'm going to put 14.5125 minus our F, which is 2.121762 M. Even members here, I am going to substitute my mg sine 30. Why? Because mg sine of 30, you know very well that g is 9.8, so we can have m times 9.8 sine of 30. So 9.8 sine of 30, you end up with 4.9. So there we shall end up with 4.9 m, because this m we don't know. So here I'm going to have 4.9 m, and this side will equal to 0.25 of m. So we shall continue and say this is 14.5125 minus. Now you'll have your 4.9 plus 2.121762. So here I'm going to get 7.021762 m is equal to 0.25 m. I collect like terms, so I'll have 14.5125 equaling to, take the negative the other side, so we shall have 7.021762 m plus 0.25 of m. So when you add, we shall end up with 14.5125 equaling to 7.271762 m. Then you divide through by on both sides, 14.5125 divided by our 7.271762 equaling to m. So when you get 14.5125, when you get 14.5125 divide by your answer, I'm getting my answer for M as 1.9 something. I don't know what for you are coming up with. Kindly let me.
1.99573.
That's what I'm also getting. The rest you could also let us know through the chat. For you, what are you getting? For you, what are you getting? Hope we are getting the same answer. Okay, looking through the chat, 1.9. Okay, good. So here it means that our mass M is going to be 1.9957. And remember, this is mass. Then we shall say these are kilograms. But now we go back to the item. What did the item want us to say? The item told us that the engineer wanted to decide whether the unknown mass was light enough to be used in the demonstration. If the maximum allowed mass on the inclined plane was supposed to be 80 kilograms. Now here, there are two things you need to know. When they use the word maximum, maximum means less than or equal to 8. It means that the biggest mass they could put here, it was supposed to be 80 kilograms. But the answer you have obtained, your mass is, where I go back. Your mass here, from what we have obtained, is 1.91. So then you make your conclusion basing on what you have obtained. So when you look at this, you note that your mass is below or it is within the acceptable range. So you could recommend accordingly that maybe they can continue to use because it is within the recommended range. So that is how you can deal with such an item in that caliber. So in case there is any question, you could ask, can I round off the answer to 2 decimal places? Now, when you round off, you'll get 2. When you round off your answer, I'm saying it's going to be 2. But here, always write it to those decimal places, unless they have advised you. But like we said, for levels of accuracy, for decimal places are very good and are good enough. For decimal places are good enough. So, in case we do not have any questions, okay, so, okay, let me first pick Arnold. Yes, Arnold?
Simisa.
Yes.
My question was on the second type of pulleys. It was on the second type of pulleys. Where we had 2 pulleys, and that one. There is a scenario I encountered whereby, for example, M3 was 4 kilograms, and then M1 was 1 kilogram, and M2 was 2 kilograms also. Whereby M1 and M2, the total number of kilograms is 4, and then for M3 it's also 4. And I wanted us to resolve. Now I was inquiring in such a case scenario, like which one which acceleration will be greater?
Okay, now there you make an assumption, but let me draw it here. You had your pulley. Let me say this is the pulley. So you said this was what, 4?
Yes.
Okay. So now let me say this is 4 Newton. And now here, let me say you have another one. And then here, there are some. Okay, what was here? You said the sum was 4. So this is
there was
1.
2 kilogram, then there 3 kilogram.
Something like this.
Yes, 3 kilogram.
So this was 2. This is 2?
No, 1.
1, eh? Okay. Now,
Yes.
if it is the case, if the thing was like this, I'm going to resolve. So this will would be 3 G newtons. Then this one is going to be your 1 G newtons. So what you do next, first put your tension. But like I've said that these strings are different. So here I'm going to come and say I can call this to be T1. Then this one is also going to be T1. So along here, I'm going to have my tension, which is T1. And also here, I'll have my tension T1. But this string is different. So I'll have here, I'll call it tension 2. I'll call it T2. I'll call this T2. I'll call this T2. And never forget that in any string, you must always put 2 arrows because action and reaction are equal and opposite. Now, when you look at these pulley systems, what are you going to notice? Here, when you are looking at your movement, I will first look at this upper section. When you look at the upper section, you notice that this 4 kilogram, because here the total is 4, but this 4 kilogram can pull this up because these two are fighting each other. This one is trying to pull down. This one is trying to pull where? Up. So what does it mean? It means that this 4 kilograms is going to weigh more than the two combined. So here, when you are considering your movement, you could have this pulley here come down. Let me say this is acceleration 1. Then here, still this pulley when it is moving, it will have its acceleration as A1. But for these two pulleys, like I've said, that what happens is that here, at this point here, this pulley is going to pull down. So it is going to move by a distance S1. So if it moves by a distance of S1, this pulley here, this one here, is also going to move up by a distance of S1. This one moves S1, this one moves S1, but this one moves up, this one moves down. Now, this S1 is what we are referring to as our acceleration. But since I've already used the A1, this one now is going to be A2 because I showed you that acceleration and displacement are proportional. So this one is also going to be A2. But this one, since this pulley is moving, where is it moving? This pulley is moving where? Up. And when you look at this distance, like for this one, if this particle moves a distance, let me say y down, this pulley also moves the distance y upwards. So that means that this particle here, the 1 kilogram, is also going to move the same distance y upwards. So here it means that the total acceleration, and like y is your acceleration, so its total acceleration is going to be A2 plus A1. But this one, since it is moving downwards, it will be A2. But since this pulley also, it is moving upwards, its acceleration is A1. Since this one is also going to be moved up, then you will say minus A1. So those are the accelerations you are going to have. So now if I'm to put them, I'll come here and I'll say that for this particle here, its acceleration is going to be A2 minus A1. Then for this particular one here, this 1 kilogram is going to be A1 plus A2. Members, first let me know through the chat whether you have understood that.
Thank you, sir.
Okay.
Excuse me,
Members,
sir.
I want some are saying no. Now, I repeat, if this is a particle and it is moving downwards, if this particle moves y distance, this pulley was initially at this point. What is going to happen to this pulley is also going to move up by the same distance y. That's what is going to happen. Now, if this is A1, because I've told that displacement is the same as the acceleration under the pulley because they are proportional. So this is going to be A1, this is going to be A1. Now, what is going to happen to these two pulleys? This pulley here, you are seeing, it is also going to be pulled up by the same distance. Why? This pulley here is also going to be pulled up a bit by the same distance. Why? That's what is going to happen. That this pulley is going to go up by the same distance. Why? However, when it comes, so this pulley here, this pulley here, if this is A1 is our Y, also here A1 will be our Y, also this one is going to have your A1, and also this one is going to have your A1. Members, have you understood that first one, where I'm putting the A1? Is that one okay? Kindly let me know whether you have understood that. Okay. Now that is okay. Now, after that, you note that there is another sweet challenge, that these two bodies here are also going to move. These two bodies here are also going, I want a better color. These two bodies here are also going to move. What is going to happen? 3 is going to be pulling downwards. Let me say it has moved a distance y2. What is going to happen on A1? A1 is also going to go up again by y2. Now, this displacement is what I told that is what we call acceleration. Now, what is going to happen? This one is going down. So let me call that one A2. This one also is going to go up. We call it A2. Now, the total acceleration acting on these two particles, there is A2 and A1. But A2 is pulling downwards, which is A2. But A1 pulled it up. So that one I will call it minus A1. When it comes to this 1 kilogram body, it has A2 and A1. A1 pulled it up, and A2 is also pulling it up. So that's why here we have A1 plus A2. Here we have A2 minus A1. Kindly let me know whether you have understood that part. Is it now clear?
Yes.
Yes, y is distance. And I showed you that y, the distance is proportional to acceleration. Okay, now that means that when you are resolving here, I'm not going to do the whole number. When you are looking at for the 4 kilogram mass, for the 4 kilogram body, what will happen that still you will say your FR is equal to MA. Now FR, 4G is greater, so you will say 4G minus T1 is equal to mass 4 times A1. Here, this is your acceleration. This is going to be one of your equations. Now, when it comes to the Pulley system here, let me call it this P. For P, let me call it P. For the Pulley system, this movable one here, it's going to be moving up. So its tension is going to be T1 minus. Down here, it's being acted on by two tensions. So it's going to be 2T2 is equal to its mass. In case they have given you the mass, in case it has the mass, but in case, also look at the question. When they tell you that it is a light pulley, then the mass is negligible. So for such a case, its mass is going to be 0 times its acceleration, which is A1. But in case they give you when it has a mass, then you will include it there. Then when it comes to this 1 kilogram, for the 1 kilogram body, what do you do? For the 1 kilogram body here, you will say that T2 is pulling up. So you will say T2 minus 1g is equal to its mass times acceleration. So its acceleration is going to be that. Then for the 3 kilogram body, for it you say 3g is pulling minus T2 is equal to its mass, then times A2 minus A1. So now you will solve these equations. You will solve these equations. You will solve those equations. So that is how you do it. Okay. Let me hope. Let me hope that is okay. Now someone has put another item, but I think the item we have dealt with, Frank, that item you have put is similar to what we have done, I think. Oh, no, it's not. Ours didn't have. Now, in case it is in that form, the one I've seen Frank has posted, Frank's scenario, I'm saying Frank's scenario is like this. So here, I hope that angle is 30 degrees. Then here, they have put 4, is it 4,600? Okay, I think it is 600. It is a pulley that it is at another pulley, which is 8 here. I think it is fixed. Yeah. Now, what happens? Now, in case your body is like this, what sorry, I was talking about this case. So when you look at this case, okay, so what now is going to happen in case this is the case? I was still showing you the resolving. So now, okay. So now when it comes to this is going now to be you resolve it, you have 800 G. Since this is the same string, the tension is the same, tension is the same. When you look at it, it is one string that is going over and over. So here you are going to have 400 G. Now you are going to start asking yourself, how is this thing going to move? Now, when you look at this system here, what are you going to notice? That this system is going to move like this. Because this is 800, it will be pulling the 600. So it will move like this. Now, as it is moving, this 800 is also going to move, is going to be pulling down. As this 800 is pulling down, this other pulley here up, it also pulls up. So what are you going to notice? Let me call this to be acceleration. Can I call it A1? So when acceleration is A1, like I've already showed you for pulley systems that are of this nature, what you do, for you first cut it, first cut away this part, first remove this part. No, which part can I remove? I wanted to. First have this part cut off. Now we say that if this is A1, what is going to happen here? That you are going to have your acceleration. I'm first cutting off. If this is A1, this string is going to be moving just half. So this one is going to be a half of our A1. Now what is going to happen? Now if for this second part here, let me see. So here, this one, you are going to have your a half of A1. Then what about this one? This one here is going to be pulling downwards. So this one is going to be pulling down. If this is A2, what is going to happen to this pulley here? It is also going to be pulled by a half of A2. What does it mean? Here you have two things. You have a half of A1, you have a half of A2. So there are two things that are acting onto the string. That is what now here you need to pay attention to. That is what now you need to pay. That's what you need to look into consideration. That here now your accelerations are going to have two accelerations that are going to be in a halves. They are going to be in a halves. So you combine those two accelerations in order for you to be able to get. So at this point, for this particular pulley system here, it is going to have two accelerations. So its acceleration is going to be the combination of A1 and A2. So here it's going to be a half of A1 minus A2. So that is how it's going to be looking like. Why is it a half A1 minus a half 2? Remember, this a half A is pulling downwards. So it is in the direction of 800. This second one, A2, is pulling upwards. That's why it is a negative. So the acceleration acting here is going to be a half of A1 minus A2. Members, are we on the same page?
Excuse me, teacher.
Yes, please.
This pulley on the incline, is it the same as this pulley, which is hold maybe to something there, which is hold connecting A2?
This is a fixed pulley. This is also a fixed pulley. This is a movable pulley. So this string here, when you look at it like this, like when you look at, when this one moves a distance, let me say of 2, this one here, this string here, it will come here and it will move. But its distance it will move is going to be a half of this first one. So that's why we are calling it a half of A1. But for this one, for it to move up, this one is going to be pulled downwards. So if this one pulling downwards has moved the A2, a distance A2, this one is going to be moving half of this distance of this particular particle, which is a half of A2. But since this particle here is moving downwards, it is being pulled downwards. That's why we say a half of A1 minus A2.
Okay, thank you.
So let me pick a hand from Bruce, Trevor, Chigolo, Fortune, and Miller.
Good morning, sir.
Morning.
My question is that at the beginning, while resolving the system, assume you interchange the direction and you use, instead of going up, like you go down and at the end you get an acceleration which is negative. You conclude by interchanging the sign, the negative of the resolution.
Now, there you come. Now, the negative on your acceleration just shows you the direction that you took a wrong direction. But you conclude and you say it is a deceleration.
Okay.
Okay. Next.
Good morning, sir.
Morning.
Sir, I'm confused on those two masses, on the other one of 400 grams and then that one of 800. I thought that one of 800 would pull down so that the acceleration too would be moving up.
Like this one is going to pull down, right?
Yes.
As this one is pulling down, this string must move up.
Okay.
So remember this string that on the pulley, it moves this side and then it goes up. But as it is going up, because this 800 kilogram, it has this body and it has this body. So you'll find that since the body is moving this side, this part is going as well as it is going up.
Yes.
Good morning, sir.
Yes, good morning.
Yes, sir. About what he asked. I thought since it's like 800 kilograms, 800 grams, it's going to pull both of them down, and now the acceleration is A1 plus A2. That's the first concern.
Okay, now let me give an example. If this is 400, someone of 400, this person here is pulling, this person is this side is pulling is maybe 300 kilograms. This person this side is pulling is let me say 200 kilograms. Where will this body move?
I think it will stay stationary.
Like each of them will have an effect on them. It can either move to this side or move to this side.
It will move on the 300 place.
But as the 300 is pulling, also this one pulls a bit.
Yeah.
Yeah. Now that's what happens to the string. That the string is going. Remember, this is the body that is moving. So the body is going to move. The string will move. Now, as the string reaches here, remember there's also another body moving. So like you can see that effort is being put this side, but also this side. So it has to move along the pulley. But it may not be able to pull both of them at the same time.
Oh, yeah. So and also my other question was, what about the scenario where there can be two pulleys, like a pulley and mounted to another pulley and another pulley, like the one that showed us of one pulley, then a string passes over the one pulley and it's connected to two pulleys. Now, what if also on the other end of the one pulley there are also two other pulleys?
Okay. I'm going to look at it a bit. I'm going to show you. Like you are saying, at this point, whereby also this side the other two pulleys.
Yeah.
Still you apply the same. Like in case there is, let me say, when it is also a movable pulley, like here, something like that.
Yeah.
Still you apply the same concepts. But here now, what you do, here the acceleration in this string will be the same acceleration here. Now here you make a decision basing on the mass, but here still when you are making the acceleration, in case you decide that your acceleration is going to come downwards, A1, what happens that this pulley is going to be pulled A1 distance downwards. Now if let me say this was 5 and this was 1, what happens that this one is going to move up. So here you'll find that you are going to have acceleration A1, A2, and F3. So here you will say that this one is going to move up, let me say by F3. If it moves by F3, this one moved by A1. So it becomes F3 minus A1. Now here, this one down, if it moves down, it will become F3 plus A1. Something like that.
Yes, sir. And then, so the last one is about the negative. What you talked about, the negative.
Yes.
When you finish calculating and you find negative acceleration, you said, what does that mean when you have a negative acceleration?
Negative, it means the deceleration. Like it means that the direction you were taking, the particle was decelerating.
Oh, okay. Thank you, sir.
Like the velocity kept on reducing. Okay, then the last one. Mila, Mwine, Sean, one of you.
Good morning,
Calvin,
sir.
Thaddeus. Yes, morning.
Sir, I have two concerns here, but I would like you to first go back to the previous slide.
This? Which slide? This?
No, the other slide where we had pulleys.
This?
No, like what no, like what you're from explaining to the other. Yeah, this one. My concern, like when we're resolving the pulleys, I noticed that it was T1 minus 2 twice T2. Like why are we saying twice T2?
Now, like here, there is T1. Then down here, you have T2. And down here, there is T2. So you have two forces downwards.
Yes.
That's why, like this pulley here, it is being acted on by two because there is a string passing. So these two tensions are pulling like downwards.
Okay. Then we go back to the current slide. Thank you, sir.
Okay.
Then the current
I go
slide.
back.
Yeah, to the current slide.
This one?
No, the one that
This
we're
one?
handling. No, the one that we're handling, the one that had 600 on the inclined pulley.
It's there.
Yes. So teacher, I wanted to know under what circumstances, like for this movable pulley, do we say that I have into brackets A1 plus A2, and then how do I know
This is
that I'm going
minus.
to be using an addition? Yes. Like how do I define that to that in this case I'm going to be using an additional sign, and then in this case I'm going to be subtracting.
Now that one will be contributed in depending on the motion of the pulleys. Take an example. In case, let me say this pulley was moving. Now, okay, what now you need to take note of is the direction for the acceleration or for the distances. Now, like when you look at A1, what happens with A1? Like when this pulley is moving, this one is going to move downwards. Acceleration on this pulley moves downwards. That is the half of A1. Then you note that as this one moves downwards, there is another acceleration here of this second one that is going to make it move. Like if this one moves by a distance of S2, this string will move up by the same distance, which is S2. Because the movement of this one depends on the movement of this one. The movement of this one makes this one move. Now, it will depend. So if this one moves up, it will be a half of this one here, which is A2. Then this part here, this one, when it moves, it makes this one move, and then it goes up. Now, it will depend on how the system is moving. In case this system, let me say it was moving up like this. So here, what happens? This one will move down, but this one will move up. Then this one will move where? Downwards. Now, it will depend on the situation. It will depend on the situation. Maybe I'll make more research and find out which situation gives us when it is a plus. But it always depends on the distance. Because if this one is A2 and it is moving up, when it comes here, it's going to move downwards. So that will be a half of A2. Then here, what is going to happen? This one is going to move upwards. So it is going to be a half of A of this one. So here, there's no way you're going to have the plus come into the play. But it can depend on the system. Though I don't have here any system that is going to giving us a plus. But in case I get one that gives a plus, then I will share on the group. Maybe in case there's anyone with one that gives a plus, you could share. It depends on how the system has been set. Okay?
Excuse me,
Thaddeus, Calvin.
Morning, sir. Good morning, sir.
Yes, morning.
Yeah, sir, my concern is about the fixed pulley.
Yes.
If we asked to get the normal reaction of the fixed pulley, how can we go about it?
Which pulley? Now, here we have two fixed pulleys. If it is for this pulley, its reaction is going to be here. So it's going to be R equals to 2T.
Okay.
If it is this one here,
Yes.
Okay. Were you here yesterday?
No, not really.
Okay, but I'll refer you to that video of yesterday. We say that what you have to first do for such a pulley is like you have, this is your reaction force here. Now, when you look here, this is 90. And when you look at the angle here, you first find that angle. So that angle is going to be 90 plus 30. 90 plus 30, which is 120. So you say 180 minus 120, which is 60. So this angle at this point is 60 degrees. So your reaction will divide it into two equal parts. So this is going to be 30 and this is going to be 30. But what are you working on? That there is tension here and also there is tension this side. So what is your task is to resolve these tensions towards this. So you'll find that your tension, when you resolve here, it's going to be T cos of that. This side, it is going to be T cos of that. So that means you'll get 2T cos of that. That's how you get now your what? Yeah, your reaction. Yeah. But we did it at in depth yesterday. But that's how you get it. Okay.
Thank you, sir. Good morning,
yes,
sir.
Calvin. Yes, morning.
Yeah, for me, my inquiry is that is this same number that we are doing kind of related to the other one, which has two inclined planes at both sides? Then the movable pulley is the one in the middle.
Oh, like you have two inclined planes?
Yes.
Okay,
one on the
I
left
think
and the other on the right. Then the movable pulley is the one in the middle.
okay. Let me draw it here. Okay, you have an inclined plane here, and then you have another one, something like this.
Yes.
Or
then I put
this.
in the middle. No, this one up with a
This
pulley
one
in the
up,
middle.
and then there is a pulley
A
somewhere here.
movable pulley.
Like here there is a pulley, and here there is a pulley.
Yes, then there is a movable pulley down here in the middle.
Like here?
Yes, like that.
Okay. You are saying?
Is it the same or is it related to this one that we are handling now?
Yes, they are related. You apply the same concepts.
Thank you, sir.
Okay. I think, I don't know members whether they have seen, because when it comes to two inclined planes, there is a scenario where you can have here a pulley, a body. Then, now, there is that one. Let me draw it, the one Calvin has told us about. Also, this one is very possible where you have, this is your inclined plane, and also this is your inclined plane. You have a pulley, there is a body being attached, there is a body being attached. Yeah, so it is also possible to be in that form. It is also possible to have something of that nature. So it means that now you need to be well conversant with the what? With the pulley. Because this one, let me say this one is bigger, this one can pull, also this one can pull. Then all of them. So that same knowledge you apply, but the most important thing, you look at the what? At the movement, at the distance being moved. You take note of that if this one moves by 2a, this one moves by a. The acceleration of a movable pulley is always half the other. The other one has.
Excuse me, teacher. Excuse me, teacher.
Sorry. I think I was muted and I never noticed that. Sorry. Yeah. Okay. Sorry. But I think I was saying that we are going to end there. But I think you were seeing what I was drawing. I was showing that we can have cases of that nature. So you could go on and practice. So I asked that maybe in the chat, you could let me know which paper one or paper two and which part should we look at, which item, because I want us to look at those items that have those components that you want us to look at.
Excuse me, teacher.
Yes, please.
Still on those pulley systems we have been drawing. I have noticed that for the movable pulley, a slight effort applied to it results into a bigger output. That's why for the fixed pulleys, they have been moving a larger distance. For it has been moving a small distance. That is what I've noticed.
Okay. That
Thank
is
you.
okay. Thank you. Okay.
But teacher, maybe we also look on that concept for parabola.
Looking through the chart. Okay, I think now we are going to go back to paper 1 because I feel we have completed all the papers. We have looked at a number from each of the sections. So we are going to go back and start now on paper 1 again. Because we looked at paper 1, we have done at least a part in each of the sections. So we shall go back and now start again with paper 1. Okay. Okay. Have a beautiful day and bye everyone. Those afternoon lessons will continue. They happen at 2 p.m. and this lesson starts at 4:30 unless there is a challenge. Unless I have a challenge somewhere. Like today, I'll let you know because there is transiting somewhere. So I'll let you know whether tomorrow we shall meet. But in case I don't communicate, we shall automatically meet. Okay. Have a good day. Yesterday's recording is available on YouTube. Yesterday's recording, you can check Holistic E-Learning Platform. That's where you can find those recordings. They are there. I usually post them.
Teacher?
Yes?
We really thank you for your efforts. You have really done a great work as far as our academic is concerned. May the Almighty Lord bless you abundantly.
I'm humbled. Thank you so much and have a beautiful day, everyone.